Hello students, today I'm going to discuss about a very important concept in chemistry required for stoichiometric calculations in chemistry, that is mole concept. And I hope you heard about this term mole in your 10th standard. So let's have a basic idea of mole concept. Now this word mole is introduced by a scientist whose name was Oswald in 1896, and this mole comes from a Latin word moles, which mean heap or pile. Now basically why it was introduced in chemistry. So in 1967 the International Union of Chemistry introduced mole as one of the basic units for measurement of amount of matter, that is amount of substance in chemical reactions, basic unit. Okay, now this amount can be in terms of grams, that is mass. It can be in terms of number of particles. What are particles? Particles can be atom, particles can be electron, particle can be proton, it can be a neutral particle, neutron. Anything can be a particle which has a mass. And plus this amount also signifies the measurement of volume of gas. Okay, so now what is mole? So basically mole is a unit of what? Measurement of amount of substance, and is measured in terms of mass, number of particles or volume of gas. Okay, let's simplify it. Have you heard about 1 dozen? 1 dozen means 12. So if I say 1 dozen of water bottles, so it means 12 water bottles. Now if I say each water bottle is of 1 liter, so you will say in total, sir, it contributes 12 liter. And if I say 1 water bottle has 1 kg of mass, so in all they have 12 kilogram of mass. So now 1 dozen can be expressed in terms of numbers. We converted that numbers into liters, that is volume, and we converted this liter into mass, kilogram. Similarly, mole can be converted into mass, can be converted into number of particles, can be converted into number of volume of gas. So basically here 1 dozen is a larger unit. Similarly, mole is also a large unit which comprises of all these things: mass, number of particles, your volume of gas. Now let us see what is the definition of 1 mole, what it has to say. Now according to International Union of Chemistry, 1 mole means number of particles present in 12 gram, which is 0.012 kilogram of carbon 12. I will discuss that. And earlier it was number of particles present in 16 gram of oxygen. Okay, and before that it is the number of particles present in 1 gram of hydrogen atom. Okay, so these are the definition, but now we use this definition more precisely. Number of particles, there's a reason behind it. We are not going to discuss about the reason. Let's not focus only on the definition of 1 mole. So 1 mole is basically number of particles present in 12 gram of C12, or number of particle present in 16 gram of oxygen, or number of particle present in 1 gram of hydrogen. So now let us find this number of particle which defines 1 mole, and for that we take a very simple example of hydrogen. Now we know that hydrogen, 99% of hydrogen exists in the form of protein, where it has 1 proton and 1 electron. Okay. Now the mass of 1 proton estimated was around 1.66 into 10 raised to minus 24 gram. Okay. And the mass of electron was 9.1 into 10 raised to minus 28 grams. Now these measurements are very difficult to understand. So what chemists have done, they have taken a value as standard. They have taken this 1.66 into 10 raised to minus 24 gram, that is mass of 1 proton, as 1 AMU, atomic mass unit, 1 U, unified mass. AMU stands for atomic mass unit, or U stands for unified mass. So if I convert this into a unified mass, the mass of electron was about 0.00055 AMU. Very less as compared to the mass of proton. So if I want to calculate mass of one single hydrogen atom, so that will be equal to mass of proton plus mass of electron, that is 1 plus 0.00055 U. And if we neglect this part, because since it is very small, we consider as 1 U, 1 AMU, as a mass of one single hydrogen atom. Okay. So if I write down here 1 atom of hydrogen, it is equal to 1 U, 1 AMU, that is equal to 1.66 into 10 raised to minus 24 gram. So 1 atom of hydrogen has a mass of 1.66 10 raised to minus 24 gram. But what if I write down, okay, X, or if I just interchange it, okay, if I divide both the side by 1.66, I get 1 atom. So if you divide both side by 1.66 10 raised to minus 24, it will appear like this, okay, 1 atom of hydrogen divide by 1.66 into 10 raised to minus 24 gram, 24 is equal to 1 gram, or I can write down 1.66 into 10 raised to minus 24 divided by 1.66 into 10 raised to minus 24 gram. So now the reciprocal of this number, 1 upon 1.66 10 raised to minus 24, is 6.022 into 10 raised to power of 23 atom of hydrogen is equal to, you cancel this, the answer becomes 1 gram of hydrogen atom. So if I say 1 gram of hydrogen atom, so 1 gram of hydrogen atom will contain 6.022 into 10 raised to 23 atoms of hydrogen. So by definition, okay, what is 1 mole? So 1 mole is nothing but number of particles. Particles can be atom, electron, proton, neutron, can be molecule, can be anything which has mass. So the number of particles present in 1 gram of hydrogen. So how many particles are present in 1 gram of hydrogen? 6.022 10 raised to 23 particles. So this is nothing but 1 mole. So if I say what is 1 mole? So 1 mole of any substance consists of 6.022 10 raised to 23 particles. Okay. And remember, now this 1 gram of hydrogen, the mass of hydrogen will be not called as atomic mass, it will be called as gram atomic mass. Okay, gram atomic mass. So one has to be clear with this idea that if I say hydrogen if I say 1 atom of hydrogen, so what is the mass of 1 atom of hydrogen? 1 U. If I say hydrogen, 1 mole of hydrogen, so it is how much? 1 gram. Acha, 1 atom of hydrogen, which can also be written as 1.66 10⁻⁻24 gram. Itna gram ho sakta hai, but actual unified mass में it will be 1 U या 1 AMU. And 1 mole of hydrogen कितना हो जाएगा? 1 gram. Now 1 mole of hydrogen consists of how many atoms of hydrogen? 6.022 into 10 raised to the power of 23 atoms of hydrogen. That will be called as 1 mole. Okay, the same thing you can obtain from carbon as well as oxygen. Let us try to understand this. How you get from the oxygen or you get from the carbon atom. Okay, so if I talk about oxygen atom, let's talk about oxygen. So before starting with oxygen, let's talk about a basic idea of isotopes from the 10th standard. Isotopes means elements having same atomic number, मतलब same position in periodic table, but different atomic mass number. Okay, different atomic mass number. Now what is mass number? Mass number is number of proton plus number of neutrons. That is called as mass number. And what is atomic number? Number of proton or number of electron. Atomic mass number is denoted by A, atomic number is denoted by Z, and any element is X, element X is represented as ZXA. Okay, so element को हम लोग ऐसा represent करते हैं, represent in this manner. And what are isotopes? Element having same atomic number. For example, carbon. The atomic number of carbon is 12, but in nature it has 2 isotopes. Okay, atomic number is 6, sorry, and in nature it has 2 isotopes, one atomic mass 12 and one atomic mass 14. So we have one carbon with atomic mass 12, one carbon with atomic mass 14, but this carbon is present in 99.9% it यही रहेगा C12 in nature, and C14 is present in very less amount. So C12 present in a very large amount. Now what is the mass of C12? Let us talk about C12. So if you talk about C12, 6C12, so 12 is the atomic mass and 6 is the atomic number. The atomic number, so what do you come to know? That it has 6 proton. Okay, what is mass number? Number of proton plus neutron. So if proton is 6, neutron will be 6. So it has 6 proton plus 6 neutron. Each proton has a mass of 1 AMU. Even neutron is almost the mass of 1 AMU. So if I say what is a mass of carbon 12 atom, single atom, so you will say, sir, mass of 6 proton plus mass of 6 neutron. Electron is neglected since mass is negligible. So now it has a mass of 6 proton, that is 6U. Mass of 6 neutron, that is 6U. That comes to what? 12U or 12 AMU. So 1 atom of C12 is equal to 12 AMU. Achha, how will you convert AMU in gram? 1 AMU is 1.66, 1 AMU 1.66 into 10 raised to minus 24 gram of carbon. I divide both sides by 1.66, so I get 1 upon 1.66 into 10 raised to minus 24 atoms of C12 is equal to 12 into 1.66 into 10 raised to minus 24 gram of carbon, divide by 1.66 into 10 raised to minus 24. So dividing both the side by 1.66, so this get cancelled out. Reciprocal of this value is how much? 6 point, again the same thing, 6.022 into 10 raised to 23 atoms of C12. That corresponds to how much gram? 12 gram of C12. So what I said, one of the definition of 1 mole, the recent definition of 1 mole, that number of particle present in 12 gram of C12. So C12 के 12 gram में how much particle is there? The same as that of present in 1 gram of hydrogen, the same as present in 16 gram of oxygen. Got it? So this will be called as what? 1 mole. So if I say 1 mole of carbon, the 1 mole of carbon, this is will be called as 1 mole. So 1 mole of carbon is equal to how much gram? 12 gram. So now 12 gram becomes a gram atomic mass of carbon. That is equal to 6.022 into 10 raised to 23 atoms of C12. Similarly, if I say 1 mole of oxygen whose atomic mass is 16, so you will say, sir, it is 16 gram, or this becomes the gram atomic mass of oxygen, or it will be equal to 6.022 into 10 raised to 23 atoms of O16. Clear? So now this number 6.022 10 raised to 23 becomes 1 mole. Remember this number becomes 1 mole, and we can also call it as Avogadro number. Okay, and it is written on behalf of a scientist whose name was Amiro Avogadro. He was an Italian physicist. I'll tell you about the history of this number later. But first try to understand, okay, this number 6.022 10 raised to 23, also called as Avogadro's number, or 1 mole of particles. Clear? So now let's take the revision of this part and let's to understand more in this. So guys, if I say 1 mole, so 1 mole means 6.022 into 10 raised to 23 particles. Okay, particles can be atom, can be molecule, can be proton, can be electron, can be neutron, कुछ भी हो सकता है, can be any. It should have a mass on it. That will be called as what? Particles. Okay. Now 1 mole can also be defined in terms of atomic mass and molecular mass. The mass of a molecule is called as molecular mass. Let us try to understand this. For example, H2O. Now H2O is a molecule. If I say what will be the mass of one single H2O molecule, so it will be one single H2O molecule will be mass of hydrogen plus mass of oxygen. There are 2 hydrogen, to 2 into mass of hydrogen atom plus mass of oxygen atom. Okay, only atom. Why atom? Because you are talking about single molecule. One single molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. 2 atom of hydrogen has a mass of 2 AMU or 2U, and oxygen has what? 16 AMU, since it has a 16 proton in it. 8 protons and 8 neutrons in it. So in total, the mass of one single molecule of water is 18 AMU. Okay. Now if I ask you to write down mass of 1 mole of water, so mass of 1 mole of water में, for 1 mole you won't write down 2 AMU of hydrogen, you will write down 2 gram of hydrogen plus 16 gram of oxygen. That comes to how much gram? 18 gram. So 18 gram becomes mass of 1 molecule of H2O. Now your H2O is a particle. Okay, so 18 gram is 1 mole of H2O. So now this 18 gram will be called as gram molecular mass. Called as what? Gram molecular mass. And in case of H2O, H2O is a particle. It's a single particle. If I say 1 mole of H2O, so 1 mole of any particles consist of how many? 6.022 into 10 raised to 23 H2O molecules in it. Okay, so 1 mole of H2O is this much of molecule, and these molecules are called as which number? Avogadro's number, which is also represent as Na. So if I say Na, it's Avogadro's number. Okay, that is equal to how much mole? 1 mole. So now 1 mole stands for this much of particle, but 1 mole also stands for gram molecular mass, और अगर वो atom होगा तो gram atomic mass. So can I say that 1 mole is also defined as gram molecular mass of substance? Yeah, gram atomic mass of substance. In short, this gram atomic mass and gram molecular mass are also called as molar mass, because this is the mass of 1 mole of a substance, and substance can be atom, can be molecule, can be proton, neutron, anything it can be. Okay, now suppose if I write down CO2, about CO2, so CO2 is a molecule. Okay, now if I say 1 mole CO2, matlab it consists of 12 gram carbon plus 2 into 16 gram oxygen, because there are 2 oxygen, that comes to 44 gram. So 44 gram becomes gram molecular mass, or in short molar mass of CO2. Now 1 mole of CO2 consists of 6.023 into 10 raised to 23 CO2 molecule. Okay, molecule together. Now if I ask you how much carbon atom it contains, so see properly, one single CO2 consists of 1 carbon. So this much of CO2 will consist of 1 into 6.023 10 raised to 23 carbon. So we can write down that 1 mole of CO2 consists of 6.023 into 10 raised to 23 carbon atoms. Acha, how much oxygen does it contain? So see properly, oxygen, one single CO2 consists of 2 oxygen. So this much of CO2 will consist of 2 into 6.023 into 10 raised to 23 oxygen atoms. So 1 mole of CO2 consists of Avogadro number of molecule, Avogadro number of carbon, and 2 into Avogadro number of O atoms. Why? Because in single molecule it has only 2 atoms. The atomicity is 2. Okay. Now for an atom, suppose मैंने sodium लिया, if I write down, if I write down 1 mole of sodium, so sodium has atomic mass of 23. तो अगेन आपके दिमाग में आएगा 23, so 23U or 23 gram. So 23U is for 1 atom, 23 gram is for 1 mole. Okay, हाँ, तो 1 mole of sodium is 23 grams of sodium. अच्छा, it contains how many atoms in it? 6.022 into 10 raised to 23 sodium atoms, Avogadro number of atoms. Simple, very simple. Okay, now let's take one more molecule. We discuss H2 as a molecule, CO2 as a molecule, sodium as a atom हम लोगों ने discuss कर लिया. Okay, अभी थोड़ा और उसको we'll try to elaborate more in terms of electrons and protons. Let's see sodium का example. Let's take more simple example in this. Okay, let's take an example of helium. Now helium as an atom, its nucleus has 2 protons, 2 neutrons, and the outermost shell has 2 electrons. The electron has a negligible mass, so we don't count the mass of electron. So if I ask you what is the mass of one atom of helium, you will say, sir, 2 proton has a mass of 2 AMU, 2 neutron has similar mass that of a proton, little bit higher but similar mass, so we take it again as 2U, each neutron 1, so 2 neutron 2, 2 protons 2, so total its mass will be 4U or 4 AMU. एक ही बात है, one and the same thing. Okay, one atom. If I say what is the mass of 1 mole of helium, you will directly write down, sir, 4 gram. And 1 mole of helium consists of how many helium atoms? Sir, Avogadro helium atoms. That is 6.022 10 raised to 23 helium atoms. Now listen to me properly. If I ask you how much proton is present in 1 mole of helium, so 1 mole of helium मतलब this much particle, this much of helium. How much? 6.022 10 raised to 23 heliums. Okay, not 1000 helium, not 10,000 helium. It will be far more. This value is humongous. So it's around 6.022 10 raised to 23 helium atoms are there, and each helium atom has 2 protons. So if I ask you in 1 mole of helium there are how many protons? So 2 into Avogadro number of protons. How many neutrons? 2 into Avogadro number of neutrons. How many electrons? 2 into Avogadro number of electrons, because each atom has 2 electrons. So this much atom will consist of 2 into. Getting it? So this is how you do the mole calculation in terms of number of particles, in terms of gram atomic mass, in terms of gram molecular mass, in terms of electron proton. Now with respect to volume, we will see that in the foundation course. This is just a basic idea of mole. In a foundation course we'll be dealing with more calculations, more serious calculations in moles with respect to mass, molecular mass, with respect to volume. And just remember one thing, this Avogadro number, okay, Avogadro is kept on the basis of scientist whose name was Amiro Avogadro, Italian physicist. He actually proposed an idea of a law where he says that 2 gases equal volume will have same number of particles. This law was rejected, but then this law, after 1856, Loschmidt was one of the scientists who actually believed in this law, proved that law, and gave a value of this constant. But that constant was not 6.022 10 raised to 23, that was 2.6 10 raised to 25. But later on, a scientist in 1909 whose name was Perrin has found out the exact value of Avogadro number, that is 6.022 10 raised to 23, and the more accurate value was found in 1933, where a scientist whose name was Virgo, with the help of X-ray diffraction method, he found out that the actual value of Avogadro number is 6.022 1199 into 10 raised to 23 experimentally. So Avogadro number is not found by Avogadro. Avogadro proposed his law in 1811, and this number was confirmed in 1933. Okay, but the name was kept because the idea, the thought process was given by Amiro Avogadro. Okay guys, so we'll see you there in the next lecture, hopefully in the foundation course. Take care, bye.